Good morning, good afternoon, good evening to you, depending where you're joining from. I want to give a presentation today on virtual commissioning made easy, turnkey solutions for your machine design challenges. But I should say the preferred title I would have for this is Of Exhaust Ports, Maplesoft, and Jailers. And I hope that if you pay attention for the next 20 minutes, that title will make a little bit more sense to you. So let's get started. But first, I always like to give like a very quick background on who we are. Maplesoft, we've been around doing engineering computation for over 33 decades. Variety of softwares. We've got the software that we build, but then also an application engineering group that can work with you to make custom solutions. The software that we're going to be talking about today is MapleSim. And I, again, like to make sure I outline, I'm going to be talking about models or simulation models, where those models fit in a spectrum. Often in the digital twin world, models can mean a whole bunch of different things, as can simulation. So on the left, you'd see sort of the game engine-based tools. They do things like product flow through a plant, and how things move, and stoppers pushing or pushing and pulling things back. So it's sequencing of events. We're sort of in the middle where we're focusing on machine dynamics. That's where MapleSim and the products we're talking about today focus. So where you combine your hydraulics, your pneumatics, your electrical, and you're using that to actuate some sort of mechanism. And what you're interested in is the dynamics and the forces at play when that thing moves. And then on the far side, you can have your FEA, where you're really focusing in on the specifics of a part, so how it flexes and bends and the stresses involved. So it's detailed part analysis, and that's more your FEA and CFD tools. Okay, so if you've been paying attention to anything in the virtual commissioning and digital twin world, you've seen a chart like this. And certainly if you've been at a Maplesoft presentation, you've probably seen something like this. And the basic idea is you've got across the bottom this, the flow of a new design project. So you've got the concept, and you go through to building a prototype, and eventually you release to market. And the simple idea is that the farther along you are when a mistake gets made, and heaven forbid that it happens when you released it into the market, the more expensive it is to fix. And sort of the main idea or the piece with that is that you can identify certain issues once a prototype is built. But if you use simulation and models, you can start to identify issues even earlier when they're less expensive to fix. And I mean, this kind of thing has been done for decades already, certainly in aerospace and automotive, and there's all kinds of studies, and I'm sure you've been sent them, about how you can improve, budget for a modeling, for a project, if you do some of this kind of work with digital twins. Or maybe you've seen something like this. This is a case study that our company has put out. And it's, a case where a company had a machine at a customer's already delivered. They didn't have a version of it sort of back at their own plant that they could do testing with. The customer had an issue with cycle times. And we built them a digital twin of that model that incorporated the dynamics, because there was a vibration issue that was causing it to not be able to run as fast. They were able to test against the virtual model and improve the controller such that they just went to the customer's site, basically did an upload, verified everything was safe, and got a 25% increase in throughput without having to change anything physically on the machine. So you hear stories like that, and it's quite likely you start to think, maybe that sounds great. But as you keep hearing more and more of it and all the different pieces involved, I think it can sometimes sort of feel like you're trying to build a Death Star, which is my representation of something that would be horribly complex and very, very, very complicated and expensive to build. And you start asking yourself questions about, well, how big of a software investment do I need for where I'm going? And, do I need to train up all my employees and all this new software? And what is the time for that? Because I've got things that I'm doing right now. And outside of all of that, am I going to be able to internally sell this to people? Will they get buy-in? Like we've worked with customers where the mechanical group at one point thought, that simulation stuff, it's hocus pocus. How do I get buy-in? Because really what you want is to be able to get value out of the process. You're not doing it just for the fact that you can say, hey, we're on the approach of building a Death Star. You've got problems you want to solve. And that's really the point, right? you might be thinking you're trying to build this, or it feels like you need to build this giant thing, but really you've got an exhaust port issue that you need to deal with and sort of focus in on amidst all of this talk of this grand digital twin and digital thread and tapestry type of thing. So we we process that and think about that here at Maplesoft. And the big question we have always is, how do we help our customers sort of make use of these digital models, these digital twins, without needing to necessarily make that, commit to the Death Star up front, the software, the training, the time? How can they start to make use of them and get a feel for how they can build their own business case for how it can be successful within their own company? And then the next question that needs to be asked is, so then not only how do we do that, but then how do we as a company change our processes, or what do we focus on in our software development to try and allow that to happen? So one answer to that, and the answer that we've sort of arrived at, is to try and remove some of the initial hurdles people have when they want to take this step towards using these kinds of models. So the idea here is that, what is one of the hurdles? Well, one of the hurdles is, can I even build this, or do I know how to start building this? So if we can take that burden away initially and say, okay, Maplesoft will build the model for you. We'll work with you to build that model, so you can immediately start working with it and seeing what kind of benefits that you can have. So you can start sizing motors, making sure that you're taking into account all the accelerations and not just doing sort of maybe a static analysis from an Excel sheet. Or you've got a vibration issue you want to investigate. See if that can be modeled inside the software, so in a safe way you can start modifying your controller right away to see how it can interact, and see if you can make progress on that control problem. It's these kinds of things that are essentially the fruits of virtual commissioning and digital twins, but you can start and experience them right away without necessarily having to commit to a full-blown software install and modeling development technology. So there's that piece. But then the second piece is, of course, the initial hurdle of a large software investment. When you've got a problem that you want to solve and you're not sure the direction, you're sometimes hesitant to put large funds towards something that you're not sure how you're going to use yet. So the goal is, can we find a way to ensure the majority of the funds of the time that are spent are at solving a problem that you actually have, something that you were going to have to spend money to solve anyways. And yet you're still investing in the future because you're starting to get a feel for, how can I use these kinds of technologies? How is there a business case for me to really go all in on these kinds of technologies? So when you start talking about this, you start talking about the idea of turnkey comes to mind. This idea that you can have something that's just ready to run. And turnkey actually has an archaic meaning that I didn't know about when we first started talking about it, and that is the idea of a jailer who's got a bunch of keys, and they can, basically someone who turns keys and opens doors. And I guess in a schmaltzy kind of way, you could think of digital twin as something that can open doors, but that's not the reason we use turnkey. It's more the idea that it's a model that you can start using and getting benefits from right away. So what would the process look like here at Maplesoft? So the first thing would be to select a exhaust port type of issue, something you're trying to solve. So we first engaged with the customer, and they said, hey, we've got this one axis on this machine we have, and it's always been a little bit soft. And we've tried at different times to solve it. It's not a burning critical issue, but it's something we've wanted to get back to. And so we sat down, modeled it for them so they could start investigating this on a virtual model. We've also had customers say, we've got this model, we're going to be shipping it out. We want to make sure that it's going to last for the long haul, and just go over and make sure we've got the torque calculations correct on that motor through the entire motion range. And so we built the model for them. And actually, in this case, it turned out that there were spikes that they hadn't gotten from their analysis they'd done in their Excel, sort of the static analysis. And they were able to say, there's some things we can change in the motion profile to remove those torque spikes and increase the longevity of the motors on the machine. But it's that kind of thing where you pick a problem that you know you have or something you're concerned about and say, okay, let's see how building a simulation model helps us solve this problem. And then once you've identified that, and we can help you do that, we would engage with Maplesoft's application engineering team. So at that point, they would help you sort of say, okay, here are the aspects of the problem that our tool could solve or perhaps, help you answer. This is the information that we would need from you in order to create that model for you. And then what the cost would be, so the time investment to create that and package it and deliver it. And then once you have that model, those models, the models that we export, they can work with your Studio 5000 or your Automation Studio or your TwinCat, depending on, what hardware that you're using or who you use to do programming. But what software on our side would you additionally need if there were some extra benefits that you wanted? And you don't necessarily have to have it, but it's, as we talk with you about what you want to do with that model, what software, if any, would be required to run the model after delivery. And then you start the process if everything looks good. So I say, what software, if any? So let's maybe unpack that a bit, because you might be thinking, I heard of you guys and you basically have Maple and MapleSim, right? So what do you mean, what software? Well, there's actually a few different levels of the software that you could use. And the reason for that is that not everybody needs the full development environment that MapleSim is. So on the bottom there is sort of the main piece there would be MapleSim. Obviously, it's a full development. You can build models, you can add and remove components, you can modify parameters. All the simulation and visualization that you would expect is there. There's apps or applications that are embedded inside of MapleSim that allow you to do things like take a given parameter, so the mass of your model, and run it through many different iterations and different values all at once, sort of programmatically, to see how that affects different aspects of your model. So maybe what the motor load is as you've changed the mass and inertia of the end effector. And you can, of course, always then use that tool to export and deploy things. But maybe your interest isn't in the build side, like we've talked about. You're happy for someone else to build the model for you. Or maybe someone else in your group doesn't need to build models, but they'd still like to be able to interact with the model and run those parameter sweeps and optimizations. Well, there's a read-only version of MapleSim called MapleSim Explorer that could be the right solution fit for you there. In this case, it's not a full development license that you need to pay for. It's really just a player license where you can start to explore and look at the model. For an even simpler interface, sort of a newer product for us now, and I'll give a little bit of a demonstration of this later, is MapleSim Insight. In this case, any of the models that we've exported there, that we've deployed, can now be made available to just be opened and run with Insight. Insight is also a companion to that exported code because it allows you to visualize, when you're running that model on any platform, it allows you to visualize what's going on inside. So it's not just plots that you're getting from the tool you're running our code in, but you've got Insight running that's actually showing you the full visualization that you saw in MapleSim while it's being run in another tool. So let's maybe, if that gives you an idea of the software, let's go through some simple kinds of things that customers might want to use the tools for, either to have us build a model for them or to explore with it. So here's a fun one. It's a really simple mechanism, just planar. You build it up out of basic components, and maybe you want to explore how friction affects things. Or you want to explore what happens when you change different masses or things like that. And it's a very simple model. This one would take less than a day probably to make if you had all the information for it. And you could put it together and start doing some exploration, or we could wrap it up for you and you could start doing some exploration with it. A little bit more complicated, maybe you're starting from CAD and you would like the CAD model put together, and now all the inertias are calculated for you. They're already in place. And what you want to do is see, okay, as I try and increase my cycle time and change the mass that I'm moving around, what happens to the absolute torque that's happening, on that motor? And you can run, in this case, you'd run probably over 50 simulations very quickly and get a result that shows you a curve like that, that shows you the relationship between those three pieces. Again, this is something where you could get this model built for you and run it in either Insight and Explorer, You don't necessarily need to be the one who builds it directly. This is the same kind of idea, only now a Deltabot. Robotics have been picking up as sort of or something that we're asked about as people are starting to say, hey, I build machines and I could use someone else's robot, but it starts to cut into my margin. If I could just do some of the basic handling on my side, I could be offering more value on the piece that I'm building. And so we've been getting requests and looks into, can you build the inverse kinematics for this piece? And so the answer is yes, and we can give you the know-how to build it, or we can give you a function that you can use with your control code that's already calculated the inverse kinematics. Speaking of inverse kinematics, I just add this one because it looks so cool. It's actually a model that we exported from MapleSim and is running in Insight. And it's got 8 different ropes pulling and changing the orientation of that box in the middle. And so you can explore, obviously, the tensions that are going on inside those ropes. But the nice thing here is, imagine building that. You don't need to calculate, what do the length of each of those ropes need to be to get a specific orientation or position of that cube. You just need to worry about making sure that the motors work the way they're working, and the controller is the interface for the user to tell it where to go is working. We can give you the right positions and give you a function for that. Okay, here's another model. I talked about apps before for doing parameter sweeps. We can also generate customized apps. So in this case, it's a simple Scaro robot, but it's an app that allows you to walk through, what are my motor torques and how do they go and how do they measure up to the ranges of torques I'm allowed, the peak or the sort of the operating torques that I'm allowed for that motor, and being able to do different kinds of analysis customized. Now, again, you can build this, you can build it in Maple Worksheet inside of MapleSim, or we can bundle it and you can just look at it in an Explorer kind of context. This is a model package of that case study that I showed you, and I include it just to sort of highlight the fact that it doesn't just have to be a mechanics only model. We can include hydraulics or pneumatics or essentially any domain that you're looking for inside of the model, bundle it and give it to you. Our default library in MapleSim includes thermal, pneumatics, and hydraulics that you can add to your system. Now, this last one is a little bit of a different domain. It's a telehandler, and I'll show a little bit more about it. But in this case, we've hooked it up to Maple. You can see right now that platform isn't level. It's going up at sort of a weird angle. We've hooked it up so that it's actually running alongside inside of Maple. And you see when the tilt compensator comes on, that's nice and straight. And the dial shows that platform is now not vibrating and bouncing back and forth. If you can kind of tell, the boom here is flexible. So it would cause a vibration on that platform while it's going. This is an example of how we can hook up Insight, that's the tool that you see right here, actually directly to Maple, where the control is coming from the widgets, the button, the dial here, and the other button over here. We've hooked it up directly, and it's actually controlling the model in real time. You can imagine this could be your control code running. It wouldn't necessarily have to be MapleSim or Maple driving that. Okay, so let's take a quick look at what Insight. It wouldn't be much of a MapleSim sort of taking a look at 2021 if we didn't show any product pieces inside here. So I'm going to open that model inside of Insight. So it's just an FMU. I've called it a telehandler. And Insight, again, is a companion. It carries all the visualization. It has a way that it'll trace out outputs of things you're interested in. Here I've got the force in the boom cylinder there, as well as the platform cylinder that's responsible for keeping that platform level. I can plot any variables in the system as I go along. And I can also, and this is the part I'm going to demonstrate, I can just run it directly here and play with it in real time. So let me start running it. It's going to start off there. You can see, and here's the control parameters. And these are just parameters that were in the model itself. So I'm going to start. I can, let's get it moving. It's going to start moving. And you can see there'll be some fluctuations there as I'm driving it. And part of the reason for those fluctuations is that that boom is flexible, remember. So there's a force acting on that boom cylinder and platform cylinder as it's moving. So I'll straighten it out. We're going to go down to that lower area. That's going to come down. And then once I'm down there, I can tell it, okay, we're in the right spot. You can stop moving. I'm just going to zoom around here so you can take it and see it from a different angle. Okay. And now we can start extending out those arms. So I'm going to put those out. Those are my stabilizer arms. And I don't know if you can see here, if I zoom in a bit, let me make sure I've got that set up. You can see those arms extending out. And I can now say, all right, we're ready to put them down. Right now, they're just coming out straight. Again, this could be, I'm playing with it here in MapleSim Insight, but quite honestly, you could be dealing with this inside. I mean, these control signals could be coming from your controller code, from your PLC. Once these stabilizers actually touch the ground, you can see we visualize the force that's acting on each of them. We can, get those exact values after the fact. And now we can start playing with the cylinder or the boom itself. So I'm going to spin it here. So it's coming to face us. I'll maybe rotate off to the side while it's doing that. And we can, extend that boom out a bit if we want, or actually you can lift the boom up so it starts to elevate. You can see the forces at play when it does that. And as it starts to elevate, you should start to see sort of an increase in the load required from that cylinder. Let me shorten this history so you'll maybe get a better view of it. There we go. Okay, now we can start to extend that boom out. It's coming out, increasing that moment arm. And so you can start to see how you would be able to explore a model, even in this very limited sort of an interface. It's a simple way of using the interface. You could get MapleSim to bundle a model like this to you. You could use it to show customers, play with ideas, see how the forces are acting on it. And at any time, you can always stop or break the simulation from the actual running piece and go back and plot something. So if I want to go see the forces here, force of one of the stabilizers in the Z direction, you can see that there was nothing until finally I put the stabilizer down, and then the different movements sort of increase the forces at different times, cause some vibrations or impulses to act. Okay, so that should give you an idea of insight, and it's a fun thing to show. So I wanted to include that as well. But I think at this point, I want to just sort of wrap up and go back to the main presentation. So to sort of summarize what I've talked about here, your first step on a digital twin might not be that you want to go and say sort of a make build where we help you build the first model, we set you up with the software you need to do the full thing. We're happy to do that. And we trust that eventually you're going to see the value and want to go that direction. But to take a first step, we've got this idea of a deploy where we can build that model for you, and we can provide you with an interactive player, either a MapleSim Explorer or a MapleSim Insight, that allows you to sort of play with that model and start to see and develop an understanding of how you can use within your company a digital twin to gain value. So I thank you very much for your time. And if you've been paying attention for the whole presentation, I hope you're able to see the connection between the jailer, the exhaust ports, and MapleSoft.